All right, so in our finding K notes, what we're doing is we're going to have to reference back to some exponential equations that we did in the last unit. So let's kind of recap what those equations were. So we have a general one that is y equals a times b to the x power. That's kind of a general. Remember, b is a scale factor, so when you have a rate, you're going to have to remember to add it to 1 or subtract from 1. And x is really your time, usually in years. So that's our kind of generic one. Number 2 was our compounded formula. So we have our new amount is based on the original amount times, and then we're going to expand on this with our plus rate divided by number of times compounded to number of times compounded times time. And this one, all you have to do is change your rate from a percent to a decimal. And the key word here will be compounded. The third one is our continuous compounded. So this one will have an original amount times e to the rate times time power. Again, rate is going to be given as a percentage, and you'll have to change it to a decimal. And then our fourth formula is more of our science application ones. So they've changed some of the variables to have more meaning, and it's still the original amount. K is a rate, but it's a constant rate, and T is still time. So we'll have to reference which one of these formulas we're going to have to use for our word problems. All right, so for our first example, we have you deposit $5,000 in an account that pays 3% annual interest, compounded quarterly is a key word that we need to use. How long will it take for the balance to reach? All right, so I've underlined and circled my question. So how long means I'm looking for time. Compounded quarterly means I have to use my compounding equation, which is our second one. So we're going to have this general form of y equals p 1 plus r divided by n to the nt power. And we're going to have to substitute in there, and everything should be filled out except for t, because that's the question that they've asked us to find. All right, so remember y is the after, what happens in the end. So in the end, I have 6,000. Right, p is the original amount, what it was in the beginning, which was 5,000. 1 plus, our rate is 3%, and we're going to change it to a decimal. N is the number of times it's compounded. Quarterly means 4 times a year. And then we substitute 4 for n again. All right, so remember, we're trying to solve t for time. So we basically need to try to isolate this much of it so that we can eventually remove t from the power position. So first I need to divide by 5,000. And so I get 1.2 equals, all of this in parentheses is a number that you can calculate, and that number is 1.0075, and now it's raised to the 4t power. All right, from here, since my base and my power has, this term has been isolated, since I cannot rewrite these bases so that they have a common base, what we're going to do is take the log on both sides. So log function on both sides. And this is helpful because when I have it in log form here, I know that my power is really a multiplier. So I can bring that down to the front. Okay, and now to get t by itself, I just need to divide by 4 and this log of 1.0075. Right, so this is an exact answer right here, and then if I want to approximate what that is equivalent to in a calculator, make sure that you are closing your parentheses before you hit the divide button, and that this is, we're dividing by both parts there, and this is approximately 6.100 years, rounding to the nearest thousands. All right, so on the next one, It's an investment service promises to triple your money in 12 years, assuming continuous compounding of interest. What rate is needed? So I'm looking for R. This word continuous means we're going to use our continuous formula here, y equals PE to the RT. That's my general. Okay, I'm looking for R, so everything else should be filled out. So if I'm tripling my money, that means if I start with $1, I should end up with 3. You could use other amounts, but it's always going to reduce to this 3-to-1 ratio. So triple the amount has this form, e to the rate, I don't know, and time is 12 years. All right, again, we have this, the base is isolated here, and I cannot rewrite these to have the same base, so what we're going to do is take the log on both sides. But since my base is e, we're actually going to do natural log on both sides, so that natural log and e will cancel. So now I have natural log of 3 equals r times 12, and to get r by itself, we're going to divide by 12. So this is my exact answer here, and then we can approximate. The number you get back in your calculator is around this. We're looking for rate though, and rate is expressed as a percent. So you're going to have to change and convert that to a percentage. So that's 9.155%. For a certain strain of bacteria, K is 0.825 when T is measured in days. How long will it take 20 bacteria to increase to 2,000? All right, so this is a science problem, and it does give you a K value. So this is, and we're going to use the science formula at the end, y equals n times e to the kt. Okay, and the question is how long? So that means we're needing to substitute values in, except for t. So y is the after amount, n is the original amount. So I'm taking it from 20 to 2,000. And k is 0.825. That's what it looks like with substitution. And this is similar to the problem above where it's me problem. So we're going to first isolate the term that has a power. And then we're going to take the natural log on both sides since I cannot rewrite my bases to match. And then to get t by itself, we just need to divide by 0.25. So again, this is my exact answer. And then we can approximate to 5.582 days. All right. An organism of a certain type can grow from 30 to 195 organisms in 5 hours. Find K for the growth formula. How long will it take to increase from 200 to 250? This one is a problem that you need to recognize as 2 parts. They give you an instruction, find K, but that's not really the final question. The how long part is the final question. So really I'm looking for T, but in order to find T, they're telling me to find K first. So this is 2 separate equations that we're going to have to build. And all of this part right here is for my second equation. So I can't use 200 to 250 until the second equation. So over here I'm looking for T. I first have to find K. Whatever I get this K value, I'm going to need to use on this side to find T. So for this side, my first equation, I have to use these amounts, 30 to 195 in 5 hours. Again, this is one of our science application problems, so we're going to use y equals n times e to the kt as our general format. Again, we're looking for k, so we've got to fill in the blanks for everything else. My ending amount is 195. My starting amount is 30. K is the unknown, and time is 5 hours. We're going to isolate the term that has the power first. Okay, and then we're going to take the natural log on both sides. And then we're going to divide by 5. So this is the exact answer. In the calculator, we're going to store what this is, and it's roughly around 0.374. But I'm doing the ellipses after it to remind myself that I have to use this stored value for k over here and not the rounded value. All right, so for my second part, how long will it take to increase from 200 to 250? So 250 is my ending amount, 200 is my starting amount. I have a k value, it's 0.374 ... and I'm looking for time this time. So again, we're going to isolate the term that has the power. We're going to take the natural log on both sides again. And then divide by 0.374, etc., our stored value. So t is around 0.596 hours. All right, a piece of machinery valued at $250,000 depreciates at 12% a year. After how many years will the value have depreciated to $100,000? On this problem, I noticed that it doesn't mention something continuous and it doesn't talk about compounding so often. And this is not a science problem, so that means I'm going to be using our general one, number 1, y equals a times b to the x power. And we got to remember that b is a scale factor, so I have to change it not only to a decimal, my percent to a decimal, but also think about if I'm adding or subtracting from 1. This is a depreciate problem, so I'm going to be doing 1 minus 0.12, and so my b value is 0.88. Okay, this problem is asking me how many years, so we're looking for time, which is x. So everything else we're going to substitute values in. So the ending amount should be 100,000. My starting amount was 250. My b value is 0.88, and we're trying to solve for x in years. So again, we're going to isolate the term that has the power. From here, I cannot rewrite these bases to be the same, so I'm going to take the log on both sides. This is really a multiplier from log rules. So that's my exact answer, and then my approximation is 7.168 years. All right, you try the last one on your own. It's half-life. Remember, half-life means my ending amount is 0.5. My beginning amount is 1. And see if you can get it. And then pause. Take your time working out the problem, and then hit unpause so you can see my work on it. All right, hopefully you notice that this is another two-step problem where first you have to find k, use that stored value for k into your next equation to solve for t. And there's all the work for that.